In this lesson, we will examine some properties of consecutive integers. Now, consecutive integers can be thought of as any successive string of values from the list shown here. So, some examples of consecutive integers include 1, 2, and 3, -7, -6, -5, and -4, as well as 3 and 4. Okay, now let's make some observations. We'll begin by examining integers that are divisible by 2. The important observation here is that every second number is divisible by 2. Next, if we examine all of the integers that are divisible by 3, we will see that every third number is divisible by 3. Similarly, every fourth number is divisible by 4, and every fifth number is divisible by 5. In general, every nth number is divisible by n. Okay, so how does this help us? Well, if we have two consecutive numbers, any two consecutive numbers, we know that one of those two numbers must be divisible by 2. In other words, one of the two numbers must be even. Similarly, if we have any three consecutive numbers, we can be certain that one of those three numbers must be divisible by 3. We can also be certain that at least one of those numbers will be even. Now, from these observations, we can formulate a rule that says if we have n consecutive integers, then one of those numbers must be divisible by n. Okay, now that we've learned a few things about consecutive integers, we need to be able to spot them. For example, we already know that these are consecutive integers, but we also need to be able to recognize that these will be consecutive integers just as long as n is an integer. For example, if n equals 7, then n plus 1 will equal 8, in which case we have two consecutive integers. Similarly, if n equals -4, then n plus 1 will be -3, in which case we still have two consecutive integers. Similarly, if n is an integer, then these will be consecutive integers, as will these and these. Okay, now let's apply this information. If n is an integer, what conclusions can we make about this expression? Well, if we recognize that we have two consecutive numbers here, then we can be certain that one of those two numbers must be even. And if we know that one of the two numbers is even, then we can also be certain that the product of the two numbers will be even. Okay, what about this expression? What conclusions can we make here? Well, to begin, let's take this expression and factor out an n. From here, we can take the n squared minus 1 and factor it to get n plus 1 times n minus 1. Finally, if we rearrange these terms, we can see that we have three consecutive numbers here, which means at least one of those three numbers is even. Now, if at least one number in the product is even, we know that the prime factorization of the expression must have at least one 2. Okay, what else can we conclude? Well, if we have three consecutive integers, we can also be certain that one of those three numbers will be divisible by 3. Now, if one of the three numbers is divisible by 3, then there must be a 3 in the prime factorization of the expression. Finally, since the prime factorization has a 2 and a 3, we know that the expression must be divisible by 6. So, these are some examples of the conclusions we can make if we are given a question involving consecutive numbers. Now, to finish this lesson, let's revisit a practice question that we examined earlier. When we first tackled this question, we used a table to study all of the possible cases. Here we noticed that the expression was even in all 4 cases, so we correctly chose B as our answer. Now let's try a different approach. We want to determine how the values of P and Q affect whether this expression evaluates to be odd or even. Now, if we recognize that these two numbers are consecutive integers, then we can be certain that one of those numbers is even. Subsequently, if we know that one of those numbers is even, we can be certain that the product must be even. If the product must be even, then the correct answer is still B. So, given the many conclusions we can make about consecutive integers, be sure to watch out for them. Just remember that they are sometimes found hiding in very unlikely places.